Meena madam, are you there? So good evening to all of you. I think I am audible and visible also. One of you respond. Am I audible?
Yes, sir. Yes, sir. You are audible and visible.
Okay, thank you. So good evening to all of you, and I welcome you to the second lecture of the faculty development program. So in this session, Dr. K.S. Beena, Professor of Civil Engineering at School of Engineering, Cochin University of Science and Technology, will be delivering a talk related to design criteria of foundations, various terminology associated with bearing capacity of soils, and the most popular bearing capacity theory, Terzigi's theory, she will be explaining, and she will be also touching upon the limitations. So before she takes over and delivers her lecture, I'll give introduction of her. Professor K.S. Beena is Dean of Faculty of Engineering at Cochin University of Science and Technology, Kochi, and she is a syndicate member of CUSAT Kochi. She is graduated in 1984 from College of Engineering, Trivandrum, Kerala, and later obtained her MTech in Civil Engineering in 1986 from the same institute. She obtained her doctoral degree from IIT Madras. She has worked under the great geotechnical professor, Professor Kurian. Some of you might have read his popular book on modern foundations. So she is the student of Professor Kurian, and she happened to be my senior at IIT Madras. She started her career as assistant professor in 1988 in Kerala Agricultural University to get hands-on knowledge of field experience in civil engineering. She took the assignment as assistant engineer in Kerala State Irrigation Department in the year 1993. After about 5.5 years of service, she joined in Cochin University of Science and Technology in 1999 as reader. From there, she has been promoted as professor and continuing in the same position for the last 15 years. She became professor in the year 2006. She has been actively involved in research and teaching. Her areas of interest include soft soil and ground improvement, liquefaction studies, geosynthetics, and natural geotextiles, gabion retaining walls, finite element modeling, transportation geomechanics, ground motions and vibration, landslide mitigation, and geo-environmental studies. So her areas of interest are diversified. She had completed 3 major sponsored projects worth around 20 lakhs and presently handling a project on liquefaction studies costing about 26 lakhs. She has guided 7 PhDs and presently she is supervising 8 more candidates for PhD program. And she has more than 75 publications in repeated national and international journals. She has delivered keynote lectures in prestigious conferences, and she has authored chapters in Springer books and all. She also has 3 scholarly books to her credit. She is serving as reviewer for many international journals. To name a few: ASC Journal of Materials in Civil Engineering, International Journal of Geophysics and Ground Engineering, Proceedings of the Institution of Civil Engineers, Forensic Engineering, ICE Ground Improvement Journal, International Journal of Geotechnical Earthquake Engineering. In addition to coordinating and organizing routine conferences and short-term courses, she played a major role in organizing the prestigious Indian Geotechnical Conference 2011, which was held in Kochi. Some of you might have attended and remembered how well that event was organized. She had been awarded with the prestigious Endeavour Research Fellowship Award as postdoctoral fellow from Government of Australia to visit and pursue research in the area of transport geotechnics at the University of Wollongong during the year 2015. And being an alumnus, she has been selected as an ambassador for the Australian Awards during 2017. She has been serving as a nominated governing body member of National Coir Research and Management Institute, Government of Kerala. She is a life member of IGS, a fellow member of Institution of Engineers India, and also an active member of many professional bodies like ISTE and IRC. So with this introduction, I invite Professor K.S. Beena to deliver her lecture on bearing capacity topic. Welcome, madam. Madam, you can share your screen and start your presentation. Your audio is muted, it seems. Kindly unmute and start. You are not audible, madam. Madam, can you hear me? Hello. Hello, madam. Hello. Okay, I'll instruct the administrator. 1 minute. Hello, I'll tell the administrator. Or earlier you have presented, na? Hello.
Yeah. That
Yeah, now it is coming.
switch off the video and then move on to system. It's coming.
Yeah, it is coming now. You can continue.
It's coming.
Yeah, it is coming.
Okay. Okay. Let me sharing. Sharing it's coming.
No. Sharing is not coming now.
Some problem with the system.
Earlier you have presented through your laptop, no? That was okay. Before 3:15 you have done, na? You have shared your presentation.
Now, yeah.
That time it was very clear.
Yeah.
Presentation was clear. Your voice was clear.
So
Maybe you can resort to that same system. Except your video, everything was good.
It's not a problem. No, I can shift to that.
No problem. 2 minutes. I think participants can wait because the system from you are presenting is not having good connectivity. Even your voice and you are breaking. So better shift to that laptop and continue your presentation.
I will switch on to the other system.
Yeah, okay, madam. Okay. Do that.
Okay.
So, sorry for the inconvenience.
Now it's coming.
No. Breaks are there. Your audio. Your video is also not moving. Audio is there. So before Beena takes over, I would like to interact with the participants of FDP. So whenever you come across, right, black cotton soils, and somebody asks for suggestion on foundation, right? So most of you will be suggesting, right, that you adopt under-rimmed pile, right? Under-rimmed pile. But is that under-rimmed pile required and best suited for expensive soils? If you have gone through recent studies on images on under-rimmed piles constructed with ground penetrating radar, right? You will be surprised to see most of the under-rimmed piles constructed right, the under reams or bulbs, right, are not getting right properly built up, right? So there is no guarantee that your unrimmed pile will be constructed as per the shape, right, and whatever calculations you are calculating coming from unbearing and from friction, right? So all issues will come. So if soil is having sufficient stiffness, forming bulb and those issues you can think of. If soil is having soft to medium consistency, sometimes side soil may flow into your right borehole that is made for construction of unrimmed pile, and concrete can mix with the soft soil. So that's why quality of pile will be poor. So in black cotton soils, right, instead of going for unrimmed piles, the latest present practice is you stick to your uniform diameter pile, but you go deeper. You go deeper instead of going for unrimmed piles. Even for shallow foundation also, in expansive soil, always you think of placing your foundation at a depth up to which volume changes do not happen with changes in moisture, right? So the depth up to which volume changes occur in expansive soil, that you right know as a active zone. So if we place our foundations well below the active zone, even shallow foundations will be able to support your structure without any problem. Okay, so always suggest, if anyone is going for shallow foundation in black cotton soil, suggest them minimum depth of 3 meter below ground level, because active zone in expansive soil, right, will be extending up to about 2.5 to 3 meter depth. So if you bypass that zone and place your foundation, right, the foundation soil will not be subjected to shrinkage and swelling, right? So that is one thing you can do. And backfilling also, in clay soils, above footing backfilling will be done with people will prefer to do with sand. Never do sand backfilling for footings in expansive soil. If you put the sand over the footing, it will feed water. It will feed rainwater directly to the bottom of the foundation and right make soil to swell. So that's why best thing is to compact or backfill with the moram soil, right? Well compacted moram is having very low coefficient of permeability. So that's why I never recommend sand backfilling for foundations laid on expansive soil. If you follow that, if you follow these two things, minimum depth of foundation 3 meter and backfilling with the well compacted moram, most of the problems you can overcome. Beena madam, are you ready? Even if somebody wants to go with black cotton soil also, they should ensure that the top bulb, the top under rim, is placed well below the active zone, right? That is below 3 meter. Code says 2.75 meter is minimum depth of right top most bulb of under rimmed pile. So one has to ensure that. So seeing that from the experience that bulbs are not being properly formed, right? It is advisable not to go for unrimmed piles. Though it is there, ancient technique, still people are using, right? It has its own drawbacks. Just I'll contact Veena madam or phone and get back to you. but your voice is not coming. Yeah, you can do that, madam. Hello, madam. So I request Chaitanya, kindly unmute the participant. Kindly mute the participant.
Okay, okay.
Surendra, just check. Bina madam is trying to log in, but she's not able to get connected, it seems. Is there anything from the admin we have to do?
So can you see the slide which I am sharing?
Yes, sir.
Okay,
Yes, sir.
so by that I think Beena has some issue. She is trying when she gets ready, I'll stop, right? Meanwhile, I would like to show some case study wherein you will realize, right, how a shear failure can happen in a soft clay when exo loading is done, right? So as you can see from the title, right, it is heaving of ground in marine clay. So in textbooks, generally, when we teach our students, right, about shear failure, settlement failure, they will not appreciate, right? So yeah, through this case study, they will realize, right, how will be the shear failure and all. So anyway, so Visakhapatnam port consists of large number of okay, so Visakhapatnam port is comprised of soft marine clay. Thick deposits of soft clay are there, extending to about 18-meter depth. So if you look at the values of standard penetration tests, right, the values will be typically, right, lying between 0 to 4. You will be surprised to see value of 0. That means without giving any blow, right, the split spoon sampler under the weight of drill rods, right, it simply, right, penetrates into soil. Such soft consistency you will notice there. The undrained corrosion, if you measure using vein shear apparatus, you will notice, right, in the range of 10 to 20 kPa. And void ratio of these marine clays, right, will be high, around 1. And compression index is, right, more than 1. And coefficient of consolidation, if you see, right, it is 1 to 2 meters per year. That means consolidation happens in marine clays at a much slower rate than conventional clays. And they are alkaline in nature. pH value will be generally more than 8. Right. So whenever you plan some construction in these soft marine clay deposits, not only you will face the problem of very low bearing capacity, even if you plan to construct by adopting such low bearing capacity, suppose N value of 4 or 5 is there. Even if you construct, you will be noticing large settlements occurring at a very slow rate. And whenever you construct some embankments, right, you will notice that there will be deep-seated slip failures. And whenever you make excavations for the purpose of foundation laying or for laying underground utilities, there will be instability, right, of soil from the excavated faces. Okay, so whenever you put extra load than which it can support, right, you will observe that under the placed loading, there is a considerable settlement, and on either side of loaded area, there is heaving of soil, right? That is what we call as shear failure. Shear failure means lateral outward upward movement of soil, right, from underneath a loaded area. Okay, so in marine clays, by chance if you are overloading at a place, the large volume displacement happening in lateral direction may exert right, lateral thrust on foundations of neighboring light structures, and they may seriously get affected. So all these problems you will encounter in soft clay deposits. So going by the right literature of our conventional bearing capacity, right, we have typical three types of shear failures, namely general shear failure, local shear failure, and punching shear failure. Okay, so general shear failure occurs in soils which are typically strong, like stiff clay or dense sand. If you have clay of medium consistency or sand of right loose to medium dense state, you will have local shear failure. And third type of shear failure you will come across in very soft clay and very loose sandy soils. So if you look at the characteristics of general shear failure, so if you try to load a footing placed on stiff clay or dense sand, by the time the footing undergoes a little settlement, you will observe development of shear zones, and that slowly results in heaving up of the ground. So as soon as failure surfaces reach to the ground surface, you will notice heaving. So for footings supported on hard soils like stiff clay or dense sand, a little downward settlement of foundation will bring in heaving of the ground, right, when external loaded. In case of clay of medium consistency or sand of loose to medium density. So there, as you try to increase the load on footing, you will observe that footing is undergoing considerable settlement, and only when footing undergoes large settlement, then you will start observing heaving of ground on either side of the footing, right? Such failure we say it as local shear failure. So difference between general and local shear failure is, in general shear failure, ground heaving on adjacent to footings is associated with small, right, compressive strains, right, below the base of the footing. Whereas in local shear failure, the ground heaving is associated with the large downward movement of the footing. In punching shear failure, as you load the footing, since soil is having very low shear strength, right, your shear zones, typically 3 shear zones you might have studied. Zone 1, pair of zone 2 on either side of zone 1, triangular, right? So triangular zone, you are calling it as the right elastic zone or elastic wedge. On either side of it, you have a pair of zones of radial shear, and you have zones of mixed shear, or in Turge's theory, we call it as a Rankin's passive, right, pressure zones, right? Such zones you will not notice for footings, right, loaded and supported in a very soft clay or a very loose sand. Only triangular wedge of soil, right, because of adhesion and friction, right, soil will stick to the underside, and along with footing, the soil mass in this triangular right wedge will be moving in downward direction, and that causes displacement of soil in lateral direction. Since soil consistency is very soft or very loose, right, the displacements will extend to large distance, and thereby in immediate vicinity you will not see any ground heaving. In earlier cases, any lateral, right, upward displacement due to downward movement of footing along with zone 1 material is resulting in upheaval of ground adjacent to footings. Whereas in third case, for footings right, laid in soft, very soft clay or loose sand, you will not find such heaving, right? No doubt there is lateral displacement, but whatever volume displacement that is occurring is spread over a larger area. That's why you are unable to see heaving, right? So these 3 types of shear failures will happen in clays or sands depending upon the consistency of soils. You might have gone through the soil, right, parameters as indicators to decide whether which type of failure is likely to happen. In case of granular soils, like right, sand, you can say general shear failure occurs if angle of internal friction is more than 36 degrees, density index ID, right, or relative density greater than 70%, standard penetration resistance N value more than 30, and void ratio less than 0.55. If any one of the parameters you know with respect to granular soil, you can say that the soil is dense, and thereby under loading it is bound to have general shear failure, right? In case of clays, if unconfined compressive strength is more than 200 right, kilonewton per meter square, you can say that the footing is likely to have general shear failure, right? So coming to local shear failure, if you have sands of loose to medium dense state, right, wherein the value of angle of internal friction will be less than 28 degrees, and N value and density index, right, code is carrying these 2 values, but they need a little debate. When void ratio is more than 0.75, you can anticipate local shear failure. If you recollect the consistency of sand based on N value, 0 to 4 value of N from 0 to 4, right, indicates that sand is in very loose state, right? 4 to 10 is loose, 10 to 30 is medium dense, right? 30 to 50 is dense state. So having stated that N value is less than 5, indirectly we are referring to very loose sand, right? So in such a soil, punching shear occurs. So only there is one value of N here, that is N equal to 5, which is referring to loose sand, right? Very loose sand, 0 to 4. So that's why. So second and third parameters that are listed and we are studying from books, right, need to be modified by IS codes. Similarly, density index 0 to 15 indicates very loose state of sand, right? So 15 to 35, is loose, right? 35 to 65 is medium dense. More than 65 is dense. So at least, right, you should have values of a density index, right? Much more than that, right? So we should say at least 15 to 65 range, we should say, to cover the consistency of sand from loose to medium dense, right? So that's why these values are wrongly decided some time back, and they are being carried, right? So anyway, we are most of the time we are going with 5. So 5 less than 28, no doubt, it refers to sand of right loose to medium dense state only. So coming to clays, if QU value unconfined compound strength is less than 100 kN per meter square or undrained cohesion less than 50 kN per meter square, you can anticipate a local shear failure to happen if overloading is done. So punching failure occurs in clay soils if CU value undrained cohesion is less than 14 kN per meter square, right? That corresponds to N value below 2. And in case of sands, right, N value below 4 indicates a punching shear, right? So if you compare this N value less than 4 and N value greater than 5 for local shear, it looks odd. There is only one N value of 5 for which you have local shear, right? So that's why don't go by that N value, right, less than 5 for local shear failure. So coming to marine clays, as they are of very soft to soft consistency, they are bound to have either punching or local shear failures. Right, so I am presenting here one of a ground heaving failure that took place in Visakhapatnam Port Trust. So a number of ground heaving failures occur in Visakhapatnam Port Trust. This I am referring because it has drawn more attention of people because of the extent of damage that has occurred. Otherwise, also every year, here and there, ground heaving failures occur and little damages will happen. So anyway, going by this failure, it happened during 2008. That time ground heaving was observed over a length of 100 meter or a distance of 15 to 20 meter, where manganese ore was stacked. Right, so the location where this heaving occurred was stackyard near H7 junction house of Visakhapatnam Port Trust. The manganese ore was stacked to a height of about 8 meter. Stacking is done in the form of an embankment. The approximate base width of the stack was 32 meter and top it was 10 meter. Right, height of stack was 8 meter, and under the stacking area, there was a substance of about 2 to 2.5 meter, and this subsidence has resulted in heaving of ground on either side with maximum heaving up to 3 meter. And the extent of heaving, right, lateral extent of heaving was about 15 to 20 meter. Unfortunately, there was a railway track passing through this zone, and it got severely affected. One minute. Hello, Chapan. 1 minute. Meeting. So here you can see the manganese ore that is stacked, right? So after the incident, since there was rain, in order to prevent water entry and to increase weight, they have covered. You can see a conveyor belt system also, right, in the background. Fortunately, it was at considerable distance and it was not affected. You can see adjacent ground, right, heaved up ground. So it has developed cracks. When underlying soil tries to come out of the ground, it splits the ground and tries to come out, right? So I'll show you the close pictures also, wherein you will be seeing right escape of very soft clay coming out of those splits. Okay. Here you can see two railway tracks, right? So in fact, this is one, this is the other one, right? You are observing as if this railway line is on slightly elevated ground. It is not like that. It was also on level ground. So this much extent of heaving occurred. So when soil lying below a railway track gets lifted up like that, right? Can railway track sustain it? It is bound to failure. You see how failure has occurred. So it is a close picture of right ground splitting, right? So through the splitted ground, you can see yellow colored. This is sulfur ore. Previously, some sulfur stacking was done and some material was remaining after removal. Some traces were there, and the black colored clay was also seen escaping through the splitted ground. Here you see the close picture of damaged right railway track. The fish plates and all got broken. You can see here, right? So as a result of this extensive damage, right, newspapers have published it as land tsunami because 2008 period, right, tsunami was popular, right? Even tsunami affected people in Chennai also. So that's why they have termed it as land tsunami or Bhu tsunami, because right, soil from underground is escaping and heaving up ground, right? And then the district administration has requested Andhra University to investigate into that. As geotechnical engineers, right, looking at the type of failure, we can attribute that it is nothing but shear failure. But anyway, we have to say it with some evidence. So that's why we have collected the information from the affected area. So the subsoil, right, investigation revealed presence of 0.3 meter right debris present at surface, followed by 0.2 meter sulfur ore, and underneath sulfur ore there was 1 meter thick moram, and underneath the moram layer there was a soft marine clay. So that was the natural soil. Even 1 meter thick moram was also dumped by a port before giving it before using it for stacking purpose, right? So natural soil was consisting of unconsolidated soft marine clay, and water table was at a depth of 2 meters below the existing ground surface. That means 0.3 plus 0.2 plus 1, that is 1.5 meter is filled up material only. That means below natural ground at 0.5 meter depth itself, groundwater table is there. So we have collected the soft marine clay after removing the heaved up soil where splitting has occurred. We have collected marine clay and tested for its properties. It has a specific gravity of 2.48. It contained more amount of fines. It has liquid limit of 65%, and it got classified as high compressible clay, and it had a high free swell index value, that is 77%, and it has density of 1.75. and if you see natural water content, it is 56.8, right? Its liquid limit is 65. So it is nearer to liquid limit, and that's why it has a very soft consistency. Undrained cohesion determined was 1.8 ton per meter square, and using basic bearing capacity theory, if you calculate net ultimate bearing capacity, it works out as 6.2 ton per meter square. So we have also collected the manganese ore that is stacked, and its properties are determined. Specific gravity, you see, it is 4.47. It is much heavier than our conventional moram also, right? Our moram soil, right, specific gravity is about 2.67, whereas it is 4.47 for manganese. This is a heavy, right, metal. Next, grain size analysis. If you see, it contained more of gravel and sand size particles. And if you look at its dry density, even in loose state, when it is dumped in loose condition also, it had a dry density of 2.58, much higher than concrete density, right? 2.4 is the right density of concrete. Okay, so in compacted state 3.2. So anyway, at stacking yard, simply they will be dumping the material. So that's why, for the sake of determining stresses induced in the subsoil prevailing there, we have adopted a dry density value as 2.58 gram per cc. Right, so considering the embankment loading due to manganese ore, right, that is stacked, right? as there is 1 meter thick compacted moram layer over the existing soft marine clay layer. So using Osterberg, right, stress distribution, we have determined the values of stresses at different points below the embankment at the level of marine clay, and at different locations the values are obtained like that. Since moram layer is there, we have taken average vertical stress because it serves like a foundation bed, right, to support your stacked material. So that's why average stress is is mentioned here. Comparing this average induced vertical stress, it is much higher than net ultimate bearing capacity of marine clay, that is, which was only 6.2, I think. So that's why it has resulted in displacement of soft clay underneath the stacked zone, and resulted in such severe damage, right? The extent of lateral heaving was up to 20 meter. So anyway, theoretically, if you refer to the Prandtl's theory, right, it is developed for punching of metals into, right, soft materials. So there the heaving, right, theoretically will be extending up to a distance of 0.707 B. Here width of your manganese ore stack is 32 meters. If you calculate, it comes it is coming around 22.6. Physically on ground also it is seen, right, that extent of heaving is up to 20 meter, right? So theory and practice with that much, right, close proximity we are getting, so we can always attribute, right, that the heaving and subsequent failure of railway track is due to large lateral right upward displacement of soft clay from the loaded area. Even the stress you can find from 2:1 dispersion also. Even if you do like that also, you can easily verify that the induced stress is much higher than ultimate bearing capacity of marine clay. Okay, so actually at the place of stacking, the incident happened overnight. So stacking will be continuing day and night. So during the daytime they started dumping, and they continued night time also. They have not noticed the heaving of the ground properly. They went on stacking, and they could notice only when a large extent of heaving has occurred and railway track not affected. Right? Had it been daytime, somebody would have warned them, and they would have stopped or removed some material and prevented damage. So in such marine soil conditions, one has to properly plan stacking up to what safe height you can place a particular material. Different materials will be stacked in ports. Some materials will be lightweighted, like coal and all. Some will be heavy. If it is iron ore, it will be still heavier. So depending upon the type of material that is being stacked, one has to be careful up to what height stacking can be done in the existing soil condition. Or else the other option is we need to improve the strength of soft clay using some ground improvement technique, like installation of stone columns, or consolidating soft clay deposit by installation of right prefabricated vertical drains, right, that need to be done. Okay. So anyway, this ground improvement, if I start right, it is a big topic. So I thought you are able to appreciate right shear failure and physically witness shear failure whenever you make any visit and you notice upheaval of ground adjacent to footing. Immediately you should suspect and you should say that shear failure has occurred, overloading has occurred there. If no heaving is seen and only footings along with columns are right going inside the ground, right, then you should say it is settlement failure. Okay, in foundation design, we should design the soil pressure, right? Safe soil pressure to be induced such that it should not, it will not lead to shear failure, and at the same time it will not cause excessive deformation of soil, so that the settlements that will be occurring will be well within permissible limits specified by the codes, right? So we have to give due consideration to settlement failure and shear failure, right? So people generally, 1 minute, Professor Veena is coming. Hello. Yeah. No, I'll call you again. I'm in some FDP program giving lecture.
Hello.
Hello, madam. You are
Hello?
able to? Yeah. We are able to hear you.
Yeah, I am trying from mobile.
Okay.
160.
So I will close, madam.
Whether I can share it from laptop, I will try.
Yeah. I'll close so that you
Two.
can.
So what is your 146? Okay. So 33 plus 16. 116.
Hello.
33
Madam,
plus
you present now.
56
I have
plus
stopped the
65
presentation.
plus 75 plus 116
Hello.
plus
Madam,
56. It is
madam,
more
we are
than
able to hear you.
60%. No? 25.
I request the participants.
392 we are getting total.
Hello.
Madam, we are able to hear you. You do screen.
Yeah.
Sharing.
Can you see my? Can you
No,
see
no.
my slides?
Not yet. We are
So
hearing
I
you.
have to open the share tray.
Yeah.
Yes, madam. Yes, you have to do that. From laptop, you need to share your screen, madam.
Yeah, from laptop I am trying to open the share tray.
Yes, madam. There you have to select desktop.
Yeah.
Then click sharing.
Share tray. Desktop.
If you click desktop, automatically the screen will be shared, madam.
Yeah, it is not coming.
No, not yet, madam. In laptop, you need to click, madam.
Pardon?
In laptop, you need to click to share the screen.
Yeah, I opened the presentation.
Okay. You have to share the screen first, madam. Then you have to start the presentation.
I am sharing it.
Come out of the presentation, madam. Share the screen first and then start your presentation. Close the presentation, madam. Now close the presentation. Close the presentation.
Yes.
Now share your screen, then open the presentation, madam.
Open screen share.
You will have desktop.
Desktop. Can you see this? Can you see my desktop?
No, not yet, madam.
Shit.
If you click on share content, automatically it will give you desktop.
Yeah, previously it came, no?
Yeah, yes, madam.
Yeah, it can yes.
Maybe it's since it is a long file, it may take some time.
No, the screen will get shared first, madam. Then the slide changing and all may take time, but the screen will shared first.
Open the share tray.
Yeah,
Okay.
Open the share tray, then you have to click on desktop.
Yeah, I clicked on desktop only.
Then it will show presenting, screen presenting.
Where I should give?
Once you click it on desktop, it will automatically be presented, madam.
It is not coming.
Ma'am, if anybody is around you,
or something.
Madam, or else can you mail your presentation so that we'll present from here and we can continue?
Yeah, that can also be done, madam.
Yeah, I can mail the presentation and I can talk from there.
Yeah,
From
that
here.
will
Yes,
be,
that
that
will be
will
better, madam.
Okay, that I'll do then.
you mail it to me, madam. Gmail you send it to me.
I'll try then that.
No. అదే నాకు పంపించమన్నాను నేను షేర్ చేస్తానండి.
Hello.
Yes, madam. Yes.
You got it?
Sir, ready, sir. You are on mute. Ready, sir. You are on mute.
You got
Yeah.
my presentation?
Yeah, it has come, madam. I'll share it now.
Sir, click on enable editing, sir. Enable editing కొట్టి slide show click చేయాలి.
అక్కడ ఉందండి, అది అంతే రావట్లేదు మేడం. కూడా ఎనేబుల్ ఎడిటింగ్ చేశాను.
Slide show, sir.
ఓకే నౌ ఇట్ విల్.
Yes.
Yeah, it has come.
Yes,
మేడం
sir. It is
కూడా అదే, మేడం కూడా ఎనేబుల్ ఎడిటింగ్ ఉంది అది.
అదే, sir.
No, it's
Madam,
okay.
Yeah, you can start, madam.
Okay. So very sorry, my sincere apologies for the delay. Just some technical problem. Very good evening to one and all. Thank you, Dr. Reddy, for your patience and your introduction too. So let us start the presentation. Can you put it in presentation mode?
Sir, Sachin Reddy, sir, it's not on slideshow.
మళ్ళీ
Pardon?
1 minute, 1 minute.
Yes, madam. Yeah, I'm just telling sir to please put it on mode.
Yeah, it is coming.
Yeah.
I think it may take some time because.
Okay.
Okay, anyway, start.
Yeah.
So I was supposed to take the
Able to see the presentation.
basics
Slide
of
is not
foundation
The slide is not
engineering, which is
visible
the very fundamental thing. The content of the presentation, slides are not visible. It is coming.
No, madam.
No more.
తేజ రావట్లేదా?
రైట్ సార్ రావట్లేదు. అదే ఒకసారి మళ్ళీ మీ డెస్క్టాప్ షేర్ కొట్టాలి సార్. షేర్ కాంటెంట్ లో డెస్క్టాప్ కొట్టాలి సార్.
ఇదిగో షేర్ ఓపెన్ ట్రేలో
డెస్క్టాప్ ఇప్పుడు వస్తుంది సార్. ఇప్పుడు పీపీటీ ఓపెన్ చేయండి సార్.
ఇప్పుడు వస్తుందా? స్లైడ్ కనిపిస్తుందా మీకు?
ఇంకా లేదు సార్. ఆ కింద పీపీటీ ఓపెన్ చేయాలి సార్.
కింద అంటే అది డౌన్లోడ్ లో ఉందా? కింద ఉన్నదా? ఓకే,
అది ఓపెన్ లోనే ఉంది కదా సార్. అది
ఓపెన్ లోనే ఉందా? ఇప్పుడు వస్తుందా?
లేదు సార్, అది ఈ స్క్రీన్ మీకు తీసుకురావాలి సార్.
ఎక్కడైనా వచ్చేస్తున్నా, ఎక్కడైనా
ఇటు రావట్లేదు సార్.
విషయం ఉందా? ఇప్పుడు చూడండి.
ఇప్పుడు వచ్చింది సార్. స్క్రీన్ మ్యాక్సిమైజ్ చేసేయండి సార్.
ఓకే ఓకే అండి.
స్క్రీన్ మ్యాక్సిమైజ్ లో లేదు సార్. అది
మ్యాక్సిమైజ్ లో
ఇది ఎగ్జిట్ కొట్టేసి స్లైడ్ షో రావాలి సార్. ఎగ్జిట్ కొట్టేసి స్లైడ్ షో. ఇది ప్రెజెంటర్ వ్యూ కదా సార్. ఇది అక్కర్లేదు. అది మ్యాక్సిమం కొట్టండి సార్. కింద స్లైడ్ షో కొట్టండి సార్.
స్లైడ్ షో కొడితే ఎలా వస్తుంది?
ప్రెజెంటర్ మోడ్ లోకి వెళ్తుంది. ఆప్షన్స్ ఉన్నాయి సార్, ఒకసారి చూడండి సార్.
ఆప్షన్స్
టాప్ లో డిస్ప్లే అనే ఆప్షన్స్ ఏ ఉన్నాయి కదా సార్.
హైడ్ ప్రెజెంటర్ వ్యూ ఉంది.
అది కొట్టండి సార్. అది కొట్టండి సార్.
ఓకే ఓకే.
ఇప్పుడు స్లైడ్ షో కొట్టాలి సార్.
స్లైడ్ షోలోనే ఉందా? ఆల్రెడీ స్లైడ్ షోలో ఉందా?
ఓకే సార్. ఇప్పుడు స్క్రీన్
It's okay. Take the first slide.
ఓకే.
ఫస్ట్
Content of the presentation. I put it like this, just an introduction.
Madam, I think one more system is on in your room. That's why echo is coming.
Yeah, now I muted that thing.
సార్ ఇట్ ఈస్ ఫ్రమ్ యువర్ స్పీకర్ సార్. మీ స్పీకర్ కంట్రోల్ చేస్తే అయిపోతుంది. హెడ్ ఫోన్స్ పెట్టుకున్నా మీరు వర్కౌట్ అవుతుంది సార్.
Okay. So okay now.
Madam, it is fine from your end.
Yeah, it's fine from my end.
Yeah.
Can you show the slides?
Yes. Now you can continue.
Yeah, though it's not in a slide show mode. Yeah, not in a slideshow mode. Okay, previous slide, please. Previous slide, please. Previous slide. Yeah. So the presentation I was planned like this. Second slide. Yeah. Introduction. Design. What are the design criteria? Types of foundations. Design load. Basic definitions. And Sagi's bearing capacity theory. These are the portions we have to cover. Actually, I don't know how much I can do it now. Anyway, I'll try my level best. For the introduction, actually every civil engineering. Next slide, please. Next slide, please. Next slide, please. Next slide, please. Dr. Reddy. Yeah. Every civil engineering structure, from the point of view of structural design, is a load-bearing system. When you say structure, this can be a superstructure or substructure. Normally, the portion above ground is considered as superstructure and below as substructure. So foundation can be considered as part of the substructure. It may be constructed with concrete, steel, or wood. So let us have some of the geotechnical structures. So next slide, please. Next slide, please. So you can see some structures of foundations. Previous one. You can see some pictures of foundations. The first one is the raft foundation, and the second one is the isolated foundation. Then over that, you can see a strip foundation. Then on the right extreme top, you can see the pile foundations and some bridge abutments, etc. Next slide, please. Now, some pictures of the retaining wall I have taken from internet. So this top stone wall, then on the right top corner, you can see the gabion walls, then reinforced concrete walls you can see. Next slide, please. Now, some of the flexible retaining systems are also there as foundation structures. Sheet pile walls, coffer dams. You can see the coffer dams also. Next slide, please. These are some of the pictures of open trench that you can can you identify the open trench? Can you? I can't put the pointer here. So please see the open trench in that, thank you. And the right corner, right picture will give the picture of a sheet pile wall, a huge sheet pile wall with a struts, one layer of struts over it. Next slide, please. So the foundation part, the foundation as part of the substructure, as we have seen, these structures are substructures. So foundation form the part of the substructures. The function of the foundation is, as we know, to transmit the load from the superstructure to the soil or rock below in a satisfactory manner as per the requirements of design. These structural elements will be in direct contact with the soil, the upper part of the earth in contact with the foundation structure, and carry the load transferring by it is known as the foundation soil. So the foundation soil and foundation is the different one. The foundation soil is the earth which is in contact with the foundation structure, is normally called as the foundation soil. Now, when we construct a structure, as an engineer, we should ensure that the structure should be stable against all sorts of loads coming over it. It should satisfy the purpose for which it is built, and it should be environmentally friendly. Here also, that is with respect to a structure. Here also, for the foundation, we should ensure that all the above three criteria, namely stability, serviceability, and environmentally adaptable, should satisfy. So stability means the foundation must not collapse or become unstable under any conceivable loading. Or in other words, soil is not overstressed. And the serviceability means the settlement of the structure must be within tolerable limits, and it should be serviceable. So if a building settles more, say around 1 feet or 2 feet in very soft soils, such things happen. If say a structure settles like that, it is not serviceable. It will not serve the purpose for which the building is built for. So the settlement of the structure must be within the tolerable limits, and it should be environmentally adaptable. That is, which will influence this environmentally adaptable criteria should influence the how and where we have to found the foundation, or fixing the location and depth of the foundation. Next slide, please. Thus, the structural foundation transmit the load from the superstructure to the supporting soil. The loads such as dead load, lie load, lateral loads, uplift and breaking forces. And the soil is not overstressed. That is, it should satisfy the shear criteria or bearing capacity criteria, and soil does not undergo deformations that would cause excessive settlements of the structure. That is the settlement criteria. Environmental or construction problems deals with the stability of excavation, bottom heave, groundwater problems, etc. Above all, we should think of the economical feasibility. Now, the structural foundation transmit load from the superstructure, as I said. All soil compress when load and cause supported substructure to settle. The requirements of foundations, as we said, the most critical factor in determining the foundation system of building is the type of soil and the bearing capacity of the soil to which the building loads are distributed. It should have adequate safety. Then the small settlements, it's actually permissible with respect to the settlement criteria. Small total as well as differential settlements are permissible, but that should be within the limit. Then the construction problems, when you say excavation problem or heave or groundwater problem, all we have to tackle during the construction time. The depth of footing may be fixed considering all these things, the environmental factors like zone of high volume due to moisture fluctuation. Next slide, please. Next slide, please. Yeah, here we can see some bearing capacity failures, pictures of bearing capacity failure, and both the buildings failed due to bearing capacity. Next slide, please. Next slide, please. Yeah, this is the second slide was the differential settlement criteria, and here also you can see the settlement. You can you see the slope line going through the building? The building original slope was there, and it's a hill slope. In the hill slope, a building was constructed, and actually the building cut on the slope, and some portion of the building is lying over the slope portion. Now, this some of the portion at the bottom corner, you see it's fill area. Some portion is fill area. So this fill area is always loose and will have settlement. So the top portions, though, remain stable. The fill area settles. That causes the differential settlement. Similarly, for the other second figure also, it's a poor bearing capacity soil is there, and building is founded on two types of soils, and the building covers both the soils. So the soft soil settle, and because of that, you can see the settlement cracks in the building. The settlement crack typically wider at the top and goes through weaker wall areas. So the large settlement, this next figure, next picture. Yeah, this one shows the large settlement and lateral spread. Settlement and can you see the settlement of that? The lateral spreading, can you see? I hope you can see the lateral spreading. Okay, now next slide, please. Now coming to the location and depth, the depth of foundation is normally defined as the vertical distance between the base of the foundation and the ground surface. It is in general actually. In the case of some bridge foundations or some structures which is on passing through the rivers, that is below seabed, such structures, the definition may vary, but in general, we can say that the depth of foundation is the vertical distance between the base of the foundation and the ground surface. Then the foundation should be laid at a depth below the level of ground movement, and the heat transmitted from the building. Now the depth of foundation should bypass zones of high volume change due to moisture fluctuations. The topsoil or organic material, peat and muck, unconsolidated materials such as abandoned garbage dumps, and similar filled in areas we should avoid. The foundation must pass through those things. Then, as a general rule, the foundation should be placed at a depth where the soil stratum has adequate strength. IS specify minimum depth of 50 centimeter below the natural ground surface. The footing depth and the spacing of foundations should be placed at an acceptable level with respect to adjacent foundations also. The foundation should be placed sufficiently away from the edge of the sloping ground. Next slide, please. Next slide, please. Yeah, this slide shows that some general requirement, that is it should have the location should have sufficient permeability, or there should not be any stagnation of water below it, and if there is a water line passing through, then there should be some impervious coating we have to do. Now, the next slide. Next slide, please. Okay, swelling in soils is another problem. You can see the swell pressure exerting on the foundation. So the foundation should be well above the swelling region, or it should pass through the swelling region, and it should be below the swelling area. So the foundation should not be placed in regions where there is swelling. Next slide, please. Okay, how close the two structures can be. The shallow foundation shall not apply any additional stresses on the foundations of the other buildings. So you can see the previous slide, you can see the load from the previous slide. Yeah, you can see the load from the adjacent structure affect even though the shallow foundation is there on the right hand side, that load from the stress from this shallow foundation affect the pile foundation, and additional load will be applied on the piles adjacent to the shallow foundation. Next slide, please. So you can see here the foundation is building is placed near a cutting excavation in a retaining wall. So if load is coming, that is on the extreme left end, if you see the stress path, that stress path will cover the cutting portion also, that leads to instability. So such things should be avoided. Next slide, please. Yeah, here also the stability you have to think of. Here, foundations are placed in a slope, so you have to think of the stability. When you place two foundations in a slope, the maximum slope between two adjacent foundations are, as shown in figure, is 3 horizontal to 2 vertical. So that is the maximum slope we can have between two adjacent foundations. Next slide, please. Yeah, here it is. We have a very interesting observation. Say an existing ground is there. It's a ground surface, but a little bit far away from there, there is a new foundation, new footing. New footing is placed over there because for placing that new footing, the excavation we are taking, that will cause soil bulges or loss of lateral support from this retaining portion on the left hand side. So you can see the following. The line from the base of the new footing to the bottom edge of the existing footing, there should be some criteria. The difference in level between adjacent foundations should not cause undesirable overlapping between stresses. So you have new footing, and when footings are to be placed adjacent to an existing structure, as indicated in the figure, the line from the base of the new footing to the bottom edge of the existing footing should be or less than 45 degree with horizontal plane. You can see the horizontal plane and 45 degree in the picture. From this requirement, it follows that the distance m of the figure, the distance m marked in the figure, that is the horizontal distance, should be greater than the difference in elevation of the two footings, that is Z. The difference in bottom of the top footing to bottom of the lower footing, that is marked as Z there. So the distance between the two footings should be minimum that the distance between the bottom and top foundations. Now next slide, please. So as I said earlier, IS 1904-1986 specify that at least 50 centimeter, the foundation should be founded at least 50 centimeter below the ground level. And there is a formula, Rankine's formula is there, which gives dF is equal to P naught by gamma into 1 minus sine phi by 1 plus sine phi square. dF is the minimum depth of foundation, P naught is the bearing capacity of the soil, gamma density of the soil or unit weight of the soil, and phi is the angle of repose. Next slide, please. So coming to the design criteria of the foundation, it involves two distinct phases. One is the geotechnical design and the other is the structural design. The geotechnical design, the aim of the geotechnical design is to arrive at the planned dimensions satisfying the twin requirement from the soil side. That is, one is the bearing capacity, which is the supporting power of the soil based on the shear criteria, and the other is the settlement, which is collectively, these two parameters collectively known as geotechnical design parameters. Now, coming to the bearing capacity of the soil, it is the maximum load the soil can bear at which the failure occurs in the bearing mode. We will discuss it in detail. What gives a soil its bearing capacity is its shear strength. The designer's job is to make sure that the pressure transmitted to the soil through the footing matches with the bearing capacity of the soil to an adequate factor of safety, such as normally we put it as 3. The foundation should be thus stable against such shear failure and overturning, such all others type of failure we normally do, shear failure, overturning failure, rotation, sliding, all these things should satisfy. Now, it should not have any objectionable settlement also. So it should be, and also it should, as we said, it should properly located. Next slide, please. So here from this picture, you can see the geotechnical parameters, bearing capacity and settlement. So the load coming over the foundation, load coming from the foundations or the superstructure along with the foundation over the soil compresses the soil below it, and the soil will give a reaction, that is soil reaction. And when the soil reaction is less than the reaction required for the soil is less than bearing capacity, this foundation is stable, and that is a stable condition. And when you think of the settlement, in terms of settlement, there is a permissible settlement for each and every type of soil as per IS code. And when we place the foundation, from the superstructure load, due to the superstructure load, the foundation settles, foundation soil settles, and that settlement should be within permissible limit. Next slide, please. Now coming to the objectives and requirement of a good foundation, the objective should be, objective is, it should distribute the load coming on the structure, it support the structure without failure, give enough stability to the structure, and also it prepare a level surface. So these are the objective of foundation, and coming to the requirement, the foundation should satisfy the stability criteria, settlement criteria, and location and economical criteria in terms of the method of installation or selection of foundation. And it should be, again, safe against corrosion or deterioration due to harmful materials in soil. And foundation and its construction should meet environmental protection standards also. The engineering judgment is required to ascertain this. All this should be, we should apply some judgment to ascertain whether all these requirements are satisfied. Next slide, please. So as a recap, we have to discuss with the various types of shallow foundations we have to discuss, and various factors affecting foundation selection. So coming to the next slide, please. Next slide, please. Next slide, please. Next slide, please. Yeah, coming to the different types of foundations, mainly the foundations are classified into shallow foundations and deep foundations. Then there is one moderately deep foundation is also there. Now, all this classification or demarcation is based on the depth and the width of the foundation. When the depth of the foundation is less than the width of the foundation, that is DF by B is less than 1, we say it is the shallow foundation. It is put at a shallow level. When it is moderately deep, DF by B should not be greater than 50. It should be less than 15, and it will be greater than 1 also. That is, in between shallow foundation and deep foundation, we have a moderately deep foundation. Then deep foundation, the load is transferred to the deep strata where BF by B is normally greater than 15. Next slide, please. Here. Okay, this foundation classification. Foundation is classified, as I said, shallow in general, shallow and deep. And in shallow foundation, we have spread or isolated footing, strip or wall footing, combined footing, strap footing, and mat footing. And in deep foundation, we have clay, that's piles and caissons, etc. Wells, caissons, piles, etc. Next slide, please. Now coming to the isolated footing, it can be rectangular footing or a square footing, and the thickness of the footing remains constant h, and you can see from the picture B, L, and H are the dimensions of the foundation, and it is embedded at a depth of DF. So it carries a single column load, also known as spread footing, since it spread the loads individual footing because it is carrying a single individual column. And under a wall, if you are putting the foundation along the wall, we will put the foundation, or we call it as a wall footing. You can see the downstream end, down end, that is right down corner. It is a wall footing or strip footing. It is having a dimension B, width of the foundation, and the length is, it varies, and it is a wall footing continuous. It is also known as continuous footing or strip footing. And so there are different types of this isolated footing based on the shape of the footing. It can be a square, rectangular, circular, stepped, or sloped footing. What you can see here on the left hand is slope footing. Next slide, please. So spread or isolated individual footing, they support, as we have discussed all those things. Strip footing, this type of footing display essentially one dimensions. It is cantilevering out on each side of the wall. Next slide, please. So these are the picture of slope footing, and the first one is in the isolated footing, slope footing, simple wall footing, the second one, then the simple column footing, the third one, the top extreme, and the bottom figure shows the stepped footing. You can see step on the foundation, steps on the footing foundations, and it is a long footing. It's under a wall, so it is a stepped wall footing. Similarly, for a column, it is given on the right hand side, column footing, that is also a stepped column footing. Now, coming if the isolated or individual is used to support column for a single column, these are provided where loads are relatively light and columns are fairly spaced apart. Next slide, please. Okay, next slide, please. So when the columns are footings, the footing has to bear two or more columns, and the combined two or more columns, they are called combined footing. The shape of this combined footing is normally rectangular, but trapezoidal footings are also used if the load from two columns are different, or if one column lies on the property line, as you can see, one column lies on the property line for the even distribution of the stresses. We have to combine it with the nearby column. The condition, there are some certain conditions where this footings, this combined footing can be used. That is when footing of two adjacent columns overlap, or one column is near the boundary, or there is another criteria when there is overturning forces acting on the footing. Then we use the other footing, nearby footing, to tie it with the adjacent footing so that the overturning moments are compensated. So you can see the pictures, rectangular combined footing, and also you can see trapezoidal, though the plan view is given, the dimension of A and B are different. Now, next footing, next slide, please. So the combined footing are designed on the basis that the line of action of the resultant must coincide with the centroid of the footing. By provision of combined footing, the risk of differential settlement is reduced. Next slide, please. Now coming to the strap footing, if two isolated footings are connected by a beam, then the whole assembly is called strap footing. When footings are at different level, they can also be joined by a strap. A strap footing is used to connect an eccentrically loaded column footing to an interior column. Next slide, please. Yeah, here we have a picture of a mat foundation. You can see it says, actually when we have a large number of columns, we have, if you are designing for a individual spread footing, the footings we have to put it in both the direction, and also the stresses from each and every footing will overlap. So if there is not sufficiently space apart. So if the strip footing in both direction is required in a large column structure, and it reduce soil pressure, so that the soil pressure will overlap, and to avoid that, we will put a raft foundation to give a suitable bearing pressure. So you can see in the picture, I think on the right hand side, individual strip footing in both the directions is shown, and you can see it's too closely spaced, and the pressure berth will also overlap. So in such cases, we'll go for raft foundations. If the sum of the area of individual footing is greater than the half of the total area of the building, then it is economical to provide a raft footing. You can see thick raft slab. So it is otherwise it is not so economical. Another advantage of raft is that it bridge over any weak pockets within the soils. So if there are a number of columns and footing of the most of the columns overlap in both directions, we provide single footing for, if we provide single footing for all columns, then we provide a slab-like structure, which is known as the mat foundation. So if some of the area of individual footings is okay, then the grillage foundation. Next slide. Next slide. We'll go to next slide, please. Next slide, please. So coming to the floating foundation, where the basement is constructed, then the weight of the overburden soil is reduced. The balance is obtained by floating foundation. That is for putting the foundation, we have to we have mat foundation, large mat foundation at a certain depth. We have to take out the soil, excavate the soil from the ground. So this soil taken away from the ground will reduce the weight over it, and it will compensate for the additional weight coming over the soil due to the structural loading. So if you can adjust the depth of the foundation in such a way that the additional load coming over the soil is approximately equal to the weight of the soil taking out from the ground, then we call it as its net intensity of loading. The net loading intensity will be 0. So we call it as the floating foundations. Then the next slide, please. The grillage foundation, it consists of single or double tier steel beams. Top tier is laid at right angle to the bottom tier. The beams are encased by concrete. It is suitable for single column load. It is normally, it's if very heavy loading is coming, we will go for this grillage foundation. Next slide, please. So when where we use these deep foundations, we said shallow foundations and deep foundation. In shallow foundation, we have seen different varieties. And the deep foundation, when depth width ratio is normally greater than 4, we will go for the deep foundation. And also where there is a low bearing capacity, we will go for a deep foundation. Then when the bearing stratum is not available, good bearing stratum is not available at shallow depths, we will go for again deep foundation. Similarly, the load coming from the structure is so heavy that the shallow foundations or strip footing or combined footing will not be sufficient to bear the load properly. Then we will go for the deep foundation. Next slide, please. In deep foundation, mainly piles and caissons are there. Piles, there are different classifications of the piles are there based on load transfer, end bearing, friction, batter, material. Depending on the material, it can be timber, concrete, steel, or composite. And depending on the method of construction, it can be driven, board, precast, cast in situ, cased or uncased piles. In caissons, it can be open caissons like well and box caissons, and pneumatic caissons are there. So the pile foundations, as we know, if the soil pressure has insufficient bearing capacity, it is necessary to use deep foundations such as pile to transmit the load to deeper, firmer strata. You can see some of the picture of deep foundations there. Then next slide. One of the very commonly used deep foundation, that is a flexible foundation, is the sheet piles. Sheet piles, there are many use. You can see the sheet piles in a Kafa Dam. Next slide, please. Okay. Next slide, please. Next slide. So the pile foundations can be timber, steel, or concrete. As we said, a structural element for transferring the load at required depth in the foundation. These are long, slender members, either driven or cast in situ, and maybe subjected to vertical or vertical plus lateral loads. Next slide, please. So you can see the different steps of pile execution. To report how the piles are driven. So I think using hydraulic jack. Reinforcement is prepared. How to lower the reinforcement. Next slide, please. So the trimmy pipe is lower here. Then after that, to the trimming, concrete is poured. Next slide, please. So over the pile caps are prepared, and after completing the pile construction, it is if a large number of piles are constructing, we have to test the piles by field test, pile load test. Slide, please. Okay. Next slide, please. So this can be, the pile can be driven pile or cast in situ pile. That is precast piles are casted in factories and brought to the site, and it's driven into the soil. And cast in situ piles, boreholes will be advanced in the soil, and the concrete will be poured in the site itself. By driving the piles, the soil is displaced. So it is high volume displaced piles based on the volume almost equal to volume of the pile. Then we say it is a high volume displaced pile. And if there is a no volume or low volume displaced piles, less volume is displaced. Next slide, please. As we said, timber, concrete, steel, or composite pile can be. Next slide. Now, the classification with respect to the load, that is how to bear the load, can be friction pile or end bearing pile. If the major part of the load is taken by the shaft of the pile, then we call it as friction pile. That is when the bearing strata of the pile is not hard enough or strong enough. The frictional resistance between the soil and the length of the pile is the force which is withstanding the load coming over it. So the friction pile where the load because of the friction developed along the length of the pile. It is mostly in clay soils we can do the friction piles. When the soil layer where the pile ends is strong enough to bear the load coming over it, we call it as end bearing piles. When end bearing pile, in most of the cases, in practical cases, it is a combination of the two friction cum bearing piles. Then, based on the function, the pile can be compression pile, tension pile, or compaction pile, fender pile, batter pile, sheet piles, etc. Compression piles are meant to resist the load coming over it. Tension pile are used to anchor the pile, and compaction pile are actually used as a ground improvement technique where the loose soil can be compacted or densified. Fender piles are mainly used near the seaport or near the harbor projects to absorb the impact loads coming from the floating objects. Again, the lateral batter piles are provided, that is inclined piles, uh, which is used to uh, support the overturning moments. Then sheet piles reduce the seepage or to provide lateral stability. Next slide, please. Next slide, please. So here, with respect to the shape of the foundation, shape of the pile, we can have round, square, octagonal, I-shaped, straight piles, tapered piles, bell-bottom piles, screw piles, etc. Next slide, please. Then this, with respect to the size, it can be large diameter pile or small diameter pile, micro pile, uh, etc. Micro piles are 4 to 6 inches sizes. Then large diameter greater than 24 inch size. These are used for specific projects. All these are depending on the load coming over it and the type of the soil. We have to decide which pipe we have to use. Then root piles are there used for special project for underpressing, that is for repair. If the piles are having very large diameter, that is greater than about 24 inches, then these are called as piers, large diameter piles. Next slide, please. Okay, this is another deep foundation, that is caissons. It's also known as we have seen open caissons and closed caissons. Open caissons are normally called as well foundations, and they are heavier in section, and they sunk to the required depth. You can see the pictures. Open caisson and pneumatic caissons where pressurized air supply is given to the workplace, and the personal access tubes are used, and the air lock is there. You can see that this picture shows the pneumatic caissons. Next slide, please. So we have seen different type of foundations, shallow foundations and deep foundations. How to choose different shallow foundations? Also, we have strip foundation, combined foundation, footing, and mat foundation. In strip foundation itself, we have seen different types, and how to choose the foundation, which foundation we have to use. That mainly depends on what structure we are going to build, what is the function of the structure, and what are the loads coming on the foundation from the structure, and what is the condition of the soil below it, and what is the cost effect. All these are the main parameters we have to look into when we say we are selecting this type of foundation. Then other environmental criteria, safety factors, risk levels, or visibility life, all this are there. Still, the principal factors are more important. What's the structure type, what is the size of the structure, what is the importance of the structure, loads coming over the size of structure, soil, subsidence conditions, including the position of water table, cost of foundation, etc. These are the major factors influencing choice the foundation. Next, please. Next slide, please. Yeah, how to select the foundation, type of foundation, that is first obtain information concerning the nature of the superstructure and the loads, what are the loads to be transmitted, what is the amount of load we have to transfer, then what is the subsurface condition. With this two things, we have to do an engineering judgment. We have to think of different possible solutions. Each and every customary types of foundations we have to see, and whether which one would be probably capable of carrying the required load, whether any a settlement will be there, all such things. Settlement and stability should be think for different types of foundations in preliminary. This is a preliminary. Then we can eliminate what are the things which are not suitable. So preliminary elimination we can do. Then after that we can make a detailed study. Even tentative designs of most promising types we can do. And these studies require some more additional informations concerning loads and subsurface conditions. And after that, we can determine the approximate size, the dimensions of the foundation. Then after that, finally prepare so from the steps up to which we can have one or two alternatives of the foundation. Then we have to consider prepare the cost estimate of each promising type and choose the best one with respect to the performance and the cost. Next slide, please. Now, coming to the foundation loads, we know the dead load, lie load, wind load, then horizontal pressure we can expect, then force from structural members we can expect, uplift forces, earthquake forces, etc. Next slide, please. So coming to the geotechnical design of this footing, we arrive at there. We said there are two types of design. One is geotechnical design and the other is structural design. So from the geotechnical design, we arrive at their plan dimensions, and we should ensure that there is adequate factor safety against the failure of the soil in bearing, and that the structure should not undergo the excessive settlement. So bearing capacity as well as settlement criteria we have to consider, and we have to select the design the planned dimensions of the foundation. Next. So for the geotechnical design of the foundation, the choice of the foundation system, first thing we have to see whether we have to go for a shallow foundation or deep foundation, depending on the load coming as well as depending on the substructural condition. So after that, we can fix the vertical location of the foundation, say DM in case of shallow foundation, that is the depth of the footing in case of shallow foundation, and the length of the pile in the case of pile, or the length of the structure, foundation structure, in the case of deep foundation. Then we have to do bearing capacity and settlement analysis and choose an appropriate value for the design pressure and we have to check whether the bearing capacity equations and settlement equations are satisfying within this design pressure. Then with that, we can fix the B and L, width and length of the foundation. Now we can evaluate the construction problems such as problem of excavation, that is if it is deep cutting, dewatering, waterproofing, water tightening, deterioration of concrete, that is if sulfate resistance, sulfate attack is there, we have to think of concrete deterioration, and we have to suggest their remedial measures also. Next slide, please. Okay. For selection of foundation type. Okay. Next slide. We have discussed all those things. Next slide, please. Okay. For depth of foundation, we have to consider all these things, and from that we have to mechanical consideration, that is we check the bearing capacity and the settlement. Next slide, please. Now coming to the bearing capacity, that is this bearing capacity normally decide on what is the area of foundation required. This area of foundation we will consider based on the loads coming on the foundation. So we have to consider all loads like dead load, lie load, wind load, or earthquake load, whatever is coming on the foundation, we have to consider. And at the same time, we have to think of the strength of the soil, that is the capacity of the soil to withstand the load over it, the strength of the soil coming over it. When the load is greater than capacity, we can expect soil failure. So as far as we want to avoid failure, the strength of the soil should be greater than the load, intensity of loading coming over it. So with the strength of the soil and the load coming over it, we can find out what is the area of the foundation. So with the area of foundation, again, we can see what is the type of foundation required. Whether it is a shallow footing is possible, or we have to go for deep foundation. So when you think of the failure, Dr. Reddy, hello, Dr. Reddy, hello.
Sir, unmute చేయాలి సార్, unmute చేయాలి.
Tell me, madam.
Okay. Can I continue? Up to what time?
Yeah, actually it is scheduled up to 5.
Yeah, that's fine.
There are delays.
Yeah. What shall I do? Can I continue now?
Or
Can I
yeah,
continue on Wednesday?
Wednesday you continue, madam, because only after you finish Tajikis theory,
Yeah.
Professor Jita will take over.
Yeah. Sure.
Okay,
So
madam.
can I continue on the Monday morning?
I'll just
Sorry,
talk.
no, Wednesday morning.
I'll just talk to Professor G.V. Rao sir and I'll inform you, madam.
Okay. I think by that time I can solve this problem also.
Yeah.
Yeah. So I mean, I'm not so.
Their network is slow. That's why you faced some problem.
I don't know. I'm.
So any questions from participants?
Yeah, I will. I actually then up to the failure condition, I will stop there. Stop now, and I will continue in the tomorrow Wednesday morning then.
Yeah.
At what time? Wednesday morning?
8:30, madam. 8:30.
Wednesday morning 8:30. Okay.
How much more time you require, madam, so that I can request Professor J.V. Rao sir to join by that time? 40 minutes will be enough.
Okay. Pardon?
40 minutes will be enough
40 minutes.
for covering rest of the portion.
Today's
Yes.
okay. Okay. Yeah. I can finish. I can cut it up. I can finish it within 40 minutes.
Okay, madam.
Now, mainly the
Basic definitions and
failure and Terzaghi's equations is there, no? So I can cover it within 40 minutes, 40-45 minutes. I can cover it. I think.
Okay.
This only basic equation is there.
Okay, madam.
So sorry. I am very sorry because since I today the department they are not because of some COVID problem. They are not allowing us to go to the department.
Okay, madam. So we ask if any queries are there from participants.
Queries are there.
So if anyone want to interact or some query, they can unmute and raise the query.
Ma'am, can you elaborate this environmental concern? See, I have seen something new. In design aspect, serviceability, and other things. What is this new thing which I observed is environmental?
Yeah, environmental factor mainly the location. Environmental on which the foundation is we are putting the foundation, that is the location of the foundation is important. That is one thing as we all think of like a environmental, that is chemical reaction that is there. That will happen only in the case of steel piles or concrete. We should take care of that environmental safety rather than if as I shown in my pictures, if two foundations are there close by, then if you put a additional foundation nearby, if you take an excavation, the soil which is supporting the existing foundation may fall down, and that will create some environmental problems to the existing structure. That is one kind of environmental, that is the environment at which we are doing our construction should be safe. That is mainly the safety aspect we have to think with respect to the environment on which we are working, whether it is adjacent foundation or whether it is on a cutting, or it is on a, as I shown, if it is on a hill place, hilly area, even though we put the foundation, because of that environment, that geography factors, there can be some disasters in later. So that is what is meant by the environmental factor. I hope you understand. It is how much spacing should we have to give from the existing foundation to the new foundation. So how the existing environment is unaffected by the new construction.
Okay, ma'am. Thank you.
Any more questions? Any more questions, please? So if there are no questions, right? So I thank all the participants for. Hello.
So if there is any question, we will discuss the Monday, Wednesday morning also. If-
So I thank all the participants for their patient listening.
Yeah, I should thank them because with so much patience they waited. So I have to thank them specially.
Yeah.
I also thank all the participants because it's unfortunate. As I told you, for the first time with using this tool, I am familiar with the Google Meet.
Yeah.
So, yeah, that is the problem, I think.
So hope things will be better from
Yeah,
Wednesday morning
things will
onwards.
things will be better on Wednesday, I think. So
I hope all the
participants. I will also try. In between, I'll also call you and.
Yeah, that will be better, madam.
Yeah. Okay.
So thank you very much, madam, for.
Thank you, Dr. Reddy. I'm very sorry.
No problem. Whatever time we got, we have utilized. I could share some case study.
Yeah, I have seen. Thanks for that.
Yeah. So thank you very much for patiently preparing slides to explain. Even
thank you. I couldn't do it, and I mean because of this time lapse in time.
Yeah.
Anyway, Wednesday we'll see. I hope we can be better.
Thank you very much, madam. We'll meet again on Wednesday morning. So thank all the participants and try to join on Wednesday on time. Tomorrow being Republic Day. So I wish all of you a happy Republic Day. And we'll close from here. And today chat box did not work. So we'll be sending fresh link tonight, so that Wednesday morning onwards, the chat box will be also available. You can pose your questions through chat box. Okay, so tonight we'll be sending again mails with new login ID. Okay, I thank you all for taking interest in the program and attending the sessions today. I hope you have enjoyed both morning and evening sessions, and certainly would have gained some extra information than what you know. Okay, so that's all for now. Okay, bye to all of you. So thank you, madam.
Thank you. Bye. Thank you. Bye.
So attendance we are directly taking from Microsoft Teams, right? So that's why we are not circulating attendance sheet. We are getting at the end of the session.